Hello everyone, welcome back. In this video, we're going to continue talking about calorimetry and energy flow. In this video, I'm going to talk specifically about the concept and problem-solving approach for heat capacity. Okay, so measuring heat really is done via the temperature. And so when we add heat to a system, the temperature increases. And the amount of heat that we add is directly related to the temperature increase, but there's this proportionality factor known as C. And what we're going to learn is that the C is what is called the specific heat. So heat capacity, or C, is the quantity of heat, or the amount of energy required to change the temperature of a material by 1 degree Celsius or Kelvin, depending upon the units. So the units of C. So specific heat is really talking about how much energy do you have to add in order for the temperature to change. And so the units of specific heat, or heat capacity, C, are going to be in units of joules per degree Celsius, or joules per Kelvin, depending upon how you're measuring your temperature. And so joules are the unit of energy, and the temperature is measured in degrees C or Kelvin. So this is the amount of heat that you have to add in order to change the temperature of the material. Okay, so there are several different versions of heat capacity. There's specific heat capacity, known as the specific heat, and it has units of joules per gram degree Celsius. This is the one that we will use the most often. Molar heat capacity is the same idea, but instead of thinking about grams of material, we're thinking about moles of material. So really with these problems, we need to watch our units carefully to make sure that we're using the correct form of the heat capacity. So how do we measure this? We measure this using a process known as calorimetry. Calorimetry is really trying to measure the amount of heat flow. And the formula for calorimetry is given as Q, heat, is equal to the mass of the species, the system, times the specific heat, times the change in temperature. And the change in temperature, delta T, is equal to the final temperature minus the initial temperature. Okay, so let's see this in action. Let's do a problem. A 55 gram aluminum block, initially at 27.5 degrees C, absorbs 725 joules of heat. What is the final temperature of the aluminum? And it gives us the specific heat capacity of the aluminum. So we're going to use our calorimetry equation, Q equals mc delta T. And I'm going to put in what we know. From the problem, we know that the mass is equal to 55.0 grams. The specific heat is 0.903 joules per gram degree Celsius. The delta T, we are looking for the final temperature, but it starts at 27.5 degrees C. And the Q is going to be the 725 joules. So I can plug this in and I get 725 joules is equal to, that's a J, 55.0 grams times 0.903 joules per gram degree Celsius. Oh, and I'm out of room. I'm gonna move things over so I got room. Okay, let's try again. So 725 joules is equal to 55.0 grams times 0.903 joules per gram degree Celsius times TF minus 27.5 degrees Celsius. Okay, so now comes some algebra. And let's do out this algebra together. So I've got 725 joules is equal to, I'm going to multiply the 55 times the 0.903, and I get 49.665. The grams cancel, so I've got joules per degree Celsius times TF minus 27.5 degrees Celsius. Now, I don't like distributing, so I'm going to divide both sides by 49.665. So 725 divided by 49.665 is 14.598. And this is the units are going to be degrees Celsius, is equal to TF minus 27.5. And so take 14.5 plus 27.5 gives me TF should be 42.1 degrees Celsius. Okay, so I hope this helps you figure out how to solve problems that are asking for the specific heat capacity. We are going to continue talking through different parts of calorimetry in the next video. I hope these are helping.